Hey guys, I thought I'd make a video to help you answer question 6 for 91625. How to use a ball screw nut technology to explain how CNC routers can achieve precision and what other machines use this tech and why. So ball screw nuts they're used to turn rotary motion to linear motion. So you have a look at one here, and this is one from our machine. So the stepper motor will be turning the screw, and this nut will move backwards and forwards in a linear motion. So it's like using rotary motion and changing it to linear motion. Okay, so it controls the axes. And if you remember, we've got 3 axes on our machine, and we've got 3 ball screw nuts. Okay, so we've got moving from side to side, which is our x-axis, moving backwards and forwards, which is our y, and then up and down, which is our z. We've got our X, Y, and Z axes on our CNC router. Now, before ball screw nuts were invented, okay, they used to use just a normal threaded shaft with a nut on it, and it used to turn. So when the shaft turned from a motor, this would move up and down in a linear way. The trouble with these is that there is a little bit of play in the nut, and so it could be preloaded and it could move, and you'd also get backlash at the end of the motion, and that made it imprecise. Okay, and you got different variances in its movement, so it wasn't very precise. So what they did is they replaced that with a nut with ball bearings inside, and the screw had could house the ball bearings really tightly. I'll show you a bit of a close-up. Okay, inside there, and so there was no preload or backlash, so there's no movement at all in that. I can't move it backwards and forwards. Really smooth. It's got low friction, so it's not going to wear, and it's really precise going backwards and forwards. Okay, so that's the ball screw nut. Okay, so there's actually 29 ball bearings in there inside the nut. Okay, and they just keep recirculating, and that's what's stopping it from moving, or any movement backwards and forwards there. You know, I literally cannot, there's no movement there at all, as you can see. So you might be interested to know that the first ball screw nut was invented in 1898. Okay, and that immediately eliminated preload and backlash, and they reckon that the precision and efficiency were like up 90% plus straight away when they invented that in all the machines in industry. That's exactly why we're using it in CNC, because we've got to be really precise, especially when, you know, when think about when we were cutting our coat hanger out, the amount of times that we cut around the same shape, it had to be exactly the same as each turn. Okay, and that's how we got the precision. So I'll just show you these parts of this. This is obviously called the screw. Okay, that's the ball nut body. This bit here is the flange that's attached to the machine. Okay, and the motor, stepper motor, is going to be on one end. Going to be a bearing on the other end with housing to move it in a linear motion. This plastic insert here, like a washer, is actually called a wiper, and it kind of keeps everything clean and makes sure there's nothing going into the ball bearings, and just keeping everything clean inside. And there's one on this side as well. Okay, and then the ball return, because the ball bearings are all lined up inside about four threads, and there's about 29 ball bearings, and there's a ball return there, and a ball return there, and then that middle one is where they put the ball bearings in when they make it, and they plug it in. The reason I know there's 29 is because when our machine broke, I took it apart and they all fell on the desk, and I quickly tried to get them all back and tried to put them in and trying to get them working, but no, I couldn't. I think I damaged one of the ball returns. Okay. There's actually the name for this, and Jack was asking the actual name for this type of ball screw nut. And so for Jack, it's cool. This is for you, Jack. It's called through the nut Z deflector ball screw nut. Okay, that's the actual name for this type. Yeah, so lots of precise machines use this technology. So all CNC machines would use it. But in addition to that, you'd have like telescopes and robotic arms and power steering in vehicles. And if you think about all three of those, you know, so you want a very precise, exactly the same movement, and you don't want any preload or backlash movements in there, and that's what it's for. So it's an awesome bit of technology that changed the world, really, because everything was able to be made very, very precisely. And yeah, I hope that helps when you're trying to describe it, because that's really really important when talking about the precision and efficiency of a CNC router. Okay, right, thanks guys, good luck, see you later.